Okay, in this video, I'm going to cover sections 8.2 to 8.4. This was class material, so if you missed class, this video is made specially for you. Um, we are in section 8.2, right here. Let's see the page number. It is page 405, and we have our first term, which is a solution. A solution is an ordered pair that makes an equation true. And so here in example 1, they want me to find the solution for y equals 3x plus 4 if x is negative 1. So you can see they have the equation, and we replace this x with this negative 1. And 3x means 3 times x. So when we replace it with negative 1, it becomes 3 times negative 1, which is negative 3, plus 4. The signs are different. Find the difference and keep the sign of the larger. The one step that you need to take is that you need to write your solution as an ordered pair. This is the number you put in, the x value, and this is the number you got out, the y value. And so we're going to do the same thing here in example 1. They give us a couple of equations and they want it for x equals negative 3. So this would be 2 times negative 3 plus 1, which would be negative 6 plus 1. The signs are different. So I find the difference and keep the sign of the larger, and my answer is the number I put in, comma, the number I got out. It's an ordered pair. In this one, negative 4 times 3 plus 3. Negative 4 times negative 3 is positive 12. Plus 3 would be 15. And again, my ordered pair would be the number I put in and the number I got out. In this one, we have y equals 0 times negative 3 minus 4. That's just 0, so I get a minus 4 or a negative 4. And again, the coordinate is the number I put in and the number I got out. Moving on to this one, a real-world example of a linear equation. They give me an equation where they say we can calculate the temperature in Celsius if we know the height in meters, which is that N. And they want to know what is the temperature at 300 meters. So you just replace this N with the 300. 0.01 times 300 is just 3. And so we get 21 minus 3, which is 18. And you could do the same thing here. And on the next page, if you had where you had 700 meters, so you would have T equals 21 minus 0.01 times the 700, replacing that N with the 700. So we're going to get 21 minus 7, and T would equal 14. Oops, went down too far. The next thing we have is another term. A linear equation is an equation whose graph is a line, and there you see that right in that word. And so we're going to be doing what we just did up here, but a few times over. And so here we're going to set up this system where we have x are the numbers we're going to pick, and then I normally say y equals negative 1/2 x plus 3. And here you can see where they've calculated, they put in negative 2 for the x. Negative 2 times negative 1/2 is 1, plus 3 is 4, and then they put in 0, and then they put in 4. And then this is the number they put in, then the number they got out. They put in 0, they got out 3, they put in 4, they got out 1. And then they plot those points. Negative 2, positive 4. Remember, your first coordinate tells you left or right. The second coordinate tells you up or down. So left 2, up 4. Left or right none, up 3. That's that point. And then right 4, up 1. And you'll notice that they connect to a dot. Now, geometrically, technically, you only need 2 points to determine a line. But the third point helps you verify that you have calculated all 3 of them correctly. If you do your points and you end up with something like this, one of those 3 points is off. You have calculated incorrectly. So let's show you how to do it with this one right here. So I'm going to say x and then y equals 2x plus 1. Give myself enough room to work, and then my xy. And I'm going to pick 3 points. Now, up here, they chose -2, 0, and 4, and they chose multiples of 2 because of that fraction right there. Because of the denominator of that fraction, it makes sense to choose multiples of 2. Since I don't have a fraction sitting in front of my x, I'm just going to pick 0, 1, and 2. So 2 times 0 is 0, plus 1 is 1, and so I have 0, 1. 2 times 1 is 2, plus 1 is 3, so I have 1, 3. And then 2 times 2 is 4, plus 1 is 5, and so I have 2, 5. So let me plot those points, and we have 0, 1, 1, 3, and 2, 1, 2, 3, 4 did not go up far enough on my grid, and 2, 5. Now, when you do these, please make sure that you use a straight edge. I do not have in this particular, this is a PDF document that I'm drawing in. I don't have any way to use that straight edge like I can in my paint program, and I can use the line feature, but use a straight edge. It doesn't have to be a ruler. You can use the side of your book, a 3x5 card, anything along that line. Okay, so right here, I'm going to do letter C, and you can see I've rewritten my equation. And because of this fraction with a 2 in the denominator, I'm going to pick multiples of 2. And by the way, I almost always am going to pick 0 to put in. And that's going to give us a coordinate which is known as the y-intercept. But anyway, so I have -1/2 times 0. That in the calculation is really easy. So I get 0 plus 4, which is 4. So my coordinate is 0, 4. Put in 2 into the equation. 1/2 of 2 is 1, but I need it to be negative because I have a negative times a positive there. The signs are different. Find the difference and keep the sign of the larger. And again, this coordinate is the number I put in and the number I got out. So -1/2 times 4 plus 4. Half of 4 is 2, and it needs to be negative because of this negative here times a positive 4. -4, positive 2, the difference is 2. Keep the sign of the larger, which was the 4. And so plotting these points, I have 0, 4. So left and right 0, up 4. Left 2, up 3. Left 4, up 2. And so there's our line right there. Now, I want to point some things out here. If you look at this equation, that plus 4 is that point right there. That, the number added or subtracted to the x, represents what is known as the y-intercept. And there are some other features to that equation, which we'll come to shortly. Okay, in example 4, they graphed the equation y equals 2. Now, if the equation is y equals 2, what that means is that y is always 2, no matter what number you put in for x. And so I have 1, 2, -1, 2, 0, 2. It's a horizontal line. And then here, they did x equals 2. But what if I had said x was 4? Well, x is always 4, no matter what y is. Y could be 1 or 3 or -1. So here I have 4, 1, 4, 3, 4, -1, and I have a vertical line at x equals 4. So x equals lines are vertical lines. Y equal lines are horizontal lines. By the way, this type of line right here is the only one that is not a function. Every other line is actually a function. It will pass the vertical line test, but this one would not because it is a vertical line. So if I drew a vertical line over it, where is it touching? The whole length of the line. And then Graphing by solving for y. So we start with this equation, 3x plus y equals -5. We want to isolate on the y, which means currently the 3x is added to it. So we are going to take that 3x, and I show this vertically rather than horizontally, and I'm going to subtract 3x from both sides. On this side, I get 0 plus y would just be y. On this side, the 3x and the 5, both of are negative, but they are not like terms, so I cannot combine them. So it's going to look like that, and we will generally write it with the x term first. So they did that, and then they went through and they picked 3 numbers and put in and graphed the thing. So let's do this one right here. I'm going to subtract 2x from both sides. So I'm going to get y equals -2x plus 3. And if I graphed that, since this is a 2 in front of there, I'm just going to pick 0, 1, and 2. It's not a fraction. I don't have to worry about it. So I have -2 times 0 plus 3. That's 0 plus 3, which would be 3. So I get 0, 3. -2 times 1 plus 3 would be -2 plus 3, which would be +1. Find the difference and keep the larger. So I get 1, 1. -2 times 2 plus 3 would be -4 plus 3, which would be -1. And I'm going to use their Cartesian plane. No, I can't use it. Hold on. So here we go. So we've got 0, 3. So left and right, none. Up 3. Right 1. Up 1. And then right 2. Okay, I have a problem here. I left off my negative. I left that off. Right 2, -1. And I noticed that as soon as I went to graph it. Because if I'd have graphed it with a +1, it would have ended up like that, and they don't line up. So I caught it as soon as I graphed it. And that's your line right there. So the last one that I'm going to do in this is this equation right here. So I would need to add 3x to both sides. That's going to give me 2y. We have 2y equals the 3x and the 6 can't go together. So I'm going to write that up here. Now, I need to get rid of the 2, which is currently multiplied by the y, so I'm going to divide by 2. Now, why did I choose to write it like this? Well, there is a reason, and it will come up when we cover the next couple of lessons. But I wanted to show you mathematically that it is logical to do that. 2 plus 6 divided by 2 is 8 over 2, which is 4. But I could also write that as 2 divided by 2 plus 6 divided by 2. 2 divided by 2 is 1, 6 divided by 2 is 3, which is 4. So when I divide by 2, I have to divide everything by 2, and that includes these things that are separated with a plus sign. They both need to be divided by 2. So over here, I'm going to get y, and I know I went up instead of down, but this is in my way. 3 over 2x plus 3. Now, let me clarify why I chose to write this as this. They are mathematically the same thing. But in the next section, we're going to learn that the number sticking in front of the x is the slope of the line. So let's go on to the next section. By the way, if you want to stop the video here and do the homework for 8.2 and then come back to the instruction for 8.3 and 8.4, that's fine. And also, by the way, the section 8.2 took more time to cover than 8.3 and 8.4 will. Okay, in section 8.3, which this did not scan very well, sorry, 8.4. In section, no, 8.3, we are going to be dealing with the slope of a line and the y-intercept of the line. So the slope of the line is the vertical change over the horizontal change. And Vertical change is the difference in the y. So another way that you can write this, and I do this often, I do this, because that little symbol right there, which is the Greek letter delta, means the difference. So we can calculate this by finding the difference in the y and dividing it by the difference in the x. They also say that this is the rise over the run. In other words, it's how the graph is slanted. So if you look at this graph here, my point, I went up 2 and to the right 4. So the rise is 2, the run is 4. On this one, to get from here down to here, I would go down 3, 1, 2, 3, and then to the right 4. So one thing I want you to notice is that to the right, the run part is always to the right. The rise part may be up or down. If it's up, it's a positive slope. If it's down, it's a negative slope. So if you look at this one right here, what is the slope of this ski trail to the right? Well, I went down 1, 2, 3. I'm going from this point to this point. So I went down 3 and to the right 1, 2, 3, 4. So my slope is negative 3/4. What if you know 2 points on the line? Then you can find the slope by the fact that the slope is the difference between the x and y, difference between the y coordinates over the difference in the x coordinates. So here's x, y, x, y. So we're going to take 3 minus 6 and 4 minus negative 2. That becomes positive. So 3 minus 6, change your sign and add. That's a negative 3. 4 plus 2 is 6. So we get negative 1/2. I will write it like this because I want that negative with my numerator. One thing to note when you do these is that one common mistake is to get the coordinates or choose in the wrong way. If you start with this coordinate for the y value, you have to start with it for the x value. So if you look, 3 and 4 both come out of the same coordinate pair. 6 and negative 2 also both come out of the same coordinate pair. So let's do these two right here. So we're going to do the difference in y over the difference in x. So I'm going to do negative 1 minus negative 7 over 8 minus 0. So I end up with 6 over 8, which is 3/4. What about this one? Change in y over change in x. So 3 minus 9 over negative 4 minus negative 10. So I get negative 6 over positive 6, which is negative 1. In example 3, they say, well, what about if we have these special cases, a y equals line or an x equals line? So let's look at this line right here. So if we found the change in y over the change in x, 2 minus 2 over negative 3 minus 1, we get 0 over negative 4, which is 0. If you take nothing and divide it among 4 people, they all get nothing. In class, I said if I decided to divide the money that I had in my pocket with everyone in the class, everyone would get nothing because I don't have any money didn't have any money in my pocket at that point. Okay, and vertical line. So we find change in y over change in x. So 3 minus negative 2 over negative 4 minus negative 4. Well, that becomes a positive, and we get 5 over 0. Well, you're not allowed to have 0 in the denominator. We say that this is undefined. And the reason why we say it's undefined is it literally doesn't match the definition of division, because that's what we're doing when we have a fraction. Division means that we take it and spread it out amongst however many are on the bottom. Well, if there is nothing on the bottom, then we are not spreading it out among them, among anything, and so we're not dividing. So we do not meet the definition of division. The slope here is undefined or does not exist. So the slope of a horizontal line is 0, but the slope of a vertical line does not exist. It's undefined. So on this one, the slope would be undefined, and on this one, the slope would be 0. In section 2 here, we have the introduction of the y-intercept of a line. And the y-intercept is the place where it crosses the y-axis. And if you look at this equation right here, which we graphed in the previous section, one of the points that we got was 0, 3. And so there it is. There's the y-intercept. This is the slope of the line, -1/2. Well, look on the line, -1/2, down 1 over 2, and I hit that point right there. This, by the way, introduces what's known as the slope-intercept form of the line, y equals mx plus b, where m is the slope and b is the y-intercept. So if we have this line right here, y equals -1/3 x plus 2. The slope, which is given the letter m, they didn't ask me my opinion, is -1/3. The y-intercept, this is a point, it's the point where it crosses the y-axis, is the point 0, 2. There's the slope, there's the y-intercept, which we write as a point. So you could actually graph an equation if it's in slope-intercept form, and that is, by the way, why on the previous section, when I did that one, I had what, 3x plus 2y equals 6. I subtracted 3x from both sides. And then when I divided everything by 2, that is why I chose to write it as y equals -3 over 2x plus 3, because that allowed me to see the slope. So I can graph this just using those two pieces of information. There's 0, 2. My slope is down 1 because it's negative, and to the right 3, and I end up right there. Now, it may be difficult for you at this point to graph using just the slope and the y-intercept. You can always plug in points and find points. If you do that, by the way, on this one, because of that 3, I would suggest 0, 3, and maybe 6. It will work for you. So let's look at this one right here. What is the slope on this one? It is 2. It's the number in front of the x, which I would write as 2 over 1 if I was going to graph it from that. The y-intercept is this -3, which is 0, -3. The slope on this one is -1. The y-intercept is 0, 4. By the way, where did the -1 come from? That's the number sitting in front of the x. So let me graph these real quick for you. So this one, I have a y-intercept of -3, and my slope is up 2 and to the right 1. So that would give me another point, and then I could connect those 2 points with a line. Okay, this one, the y-intercept is 0, 4. The slope is down 1 and to the right 1. Notice I always go to the right. The negative tells me whether I go up or down. And so I could graph using that. Okay, that finishes up 8.3. 8.4. 8.4 introduces function notation. This is used more in upper level math classes. And basically what you're doing is replacing the y with this notation right here, which is read f of x. What that means is that f is a function of x. So like if you were doing distance equals rate times time, you could also write this as the distance is a function of the rate, and then have something else in there. And all that's telling me is that one is a function, which remember has its own definition. It's a set of ordered pairs or a relation where there's no repeat in the domain. So here's these two things are the same. All they've done is replace that with that. It's a little slightly different notation. I'm not going to stress over it too much, um, but it's just a different way of writing things. So in example one, Paulo works at a local store. Each week he earns $300 plus 3% commission on his sales. So how much does he make? So we're going to let S equal his number of sales. T is his total earnings. So they did the function T of S. So his total earnings is a function of his sales. There's the 300 that he gets as a base salary plus 3% times the number of sales. So this is the equation that we got from that. And then you could use that. They used it to solve for 20. If the number of sales was 2,500, they replaced this X with 2,500. And you'll notice here, they replaced it here. This is not T times 2,500, it's T of 2,500. That is why when we were learning this notation and we did the distributive property, we called 3 times X 3X. We did not call it this because later on when you use function notation, you don't want to confuse 3 times X with X of 3. So here, F of 25, T of 2,500 is $375. So he earns $375 if he has 2,500 in sales. The snack company sells things for $3 per pound plus 40 cents shipping, $44 shipping and handling. Write a function rule C of P, and P would be pounds. So the total cost is going to be $3 per pound plus the $4 of shipping and handling. And then they want to know what is the value if I put in 5 pounds. So C of P, C of 5 is 3 times 5 plus 4. 15 plus 4 is 19. And then finally, they have, what if we want to write the equation? Can we write the equation of a function? And yes, we can if it's a linear function. Remember, in the slope-intercept form, I need two pieces of information to write the equation. I need the slope and the y-intercept. So if you look at this set right here, this is the y-intercept. So y equals mx plus b. Well, b is 1, and it's a positive 1. The next thing I need is the slope, which is the difference in the y, change in y, over change in x. Well, the y's from 1 to 7 go up by 6, 7 to 13. They went up by 6, and while the x's went up by 2. So the slope is 3. And so I can replace that with a 3. Let's look at these here. And by the way, this could be y. It should probably be f of x since that's an f of x there. Again, I'm not stressing over that. So let's look at this example. X is going up by plus 1, from 0 to 1, 1 to 2. Y is going up by plus 2. So my slope is the difference in the y over the difference in the x. Plus 2 over plus 1, so my slope is 2. Plus b, there it is 0. So we would just write that as 0 equals 2x. Let's do this one. And you'll notice I don't have to do all of them. That went up by 3, that went up by 3. This went down by 6, and then down by 6 again. So my slope is a negative 6 over a positive 3, which is negative 2. So y equals negative 2x, and then there's my y-intercept again, plus 0. So this would just be y equals negative 2x. Let's do this last one. X is increasing by 2. y is increasing by 4. That's the difference between those. So change in y over change in x, 4 over 2 would be 2. There's my m. B is 1. So there's my equation for that. In these, it's the same thing except they give you a graph. So here's my y-intercept. So there's that -1. And then the slope, you just need to calculate the slope. Change in y, 1 minus -1. They did that there. Over 4 minus 0. So we get 2 over 4, which is 1/2. And that 1/2 came in there. Okay, let's look at this one. So y equals mx plus b. It's not marked, but there's the b. That's where it's crossing the y-axis at 0, 2. So that's 2. The slope is change in y over change in x. Again, note that the 4 and -2 come from the same coordinate pair. So we get 3 over -3 or -1. So you could write it like that, or you could just write it as -x plus 2. And so that's what we covered in sections 8.2 to 8.4.